The Vernier flash photolysis spectrometer is a time-resolved spectrometer designed for measuring photochemistry in the college classroom. In the teaching laboratory, kinetic studies usually involve mixing two solutions, which starts the reaction of interest. The reaction is then followed in time by monitoring the change in a physical property of the reaction system. This process is suitable for reactions which take place on the scale of minutes or longer, but many reactions take place much faster than this and need special instrumentation to examine. Examples of these reactions include excited state dynamics, triplet state phosphorescence, isomerization, reactive free radicals, and photocatalysis. The Vernier flash photolysis spectrometer is an example of a specialized instrument used for studying these fast, light-induced reactions. A block diagram of this system appears on the top of the instrument. In the system, a xenon flash lamp provides the photoexcitation pulse. Then white light from an LED source probes any spectral changes made in the system by the excitation light pulse. The white light from the LED source is focused on a sample. From the sample, this beam goes through a wavelength filter while being focused on a photodiode which detects the light intensity. If the flash lamp causes changes in the absorption at the filter's wavelength, the detector will measure these changes. The voltage from the detector is collected, digitized, and stored versus time in a CSV file, which may be analyzed in Logger Pro software. To use the Vernier flash photolysis spectrometer, you first need to download the free software from our website. From here, you can see the photodiode level, the type of experiment, the time window or time duration, and the number of samples to average. The reaction I will be demonstrating today is the excited state cis-trans isomerization of a substituted carbon-carbon double bond in the Congo red dye. This is one of the free experiments available in the full reference manual on our website. I've prepared the sample as described in the experimental write-up. The instrument needs to be plugged into AC power and into the USB of the computer and turned on. At this point, the photodiode level should be at max, about 2.5 volts. I'm going to be using the 600 nanometer filter that ships with the device, and once I set it in the filter slot, the photodiode level should drop to about half. I can then insert my Congo red sample into the sample cell, and the photodiode level should drop a little bit further. The time window for this experiment should be 1 second. For preliminary runs, 10 averages should be sufficient. The more averages you collect, the less noisy your data will be. Now I'm ready to collect data by pressing run. Here is the kinetic trace for the photoisomerization of Congo red. By looking at the trace, I can estimate the time constant to be about 800 milliseconds. I can save this data as a CSV file and import it into Logger Pro for analysis, including exponential fits to get more precise time constants. Once I've saved this data, as the experiment describes, this cis-trans isomerization can be further catalyzed by adding a base to the solution. My next sample contains 2 millimolar sodium hydroxide. If I put that sample in the instrument and measure the isomerization on the same time scale, you'll see that it happens much faster . In fact, it happens in less than 100 milliseconds. This instrument is great for physical chemistry, biochemistry, inorganic chemistry, and instrumental analysis courses. It is also ideal for student projects. For more information, see our website or email chemistry@vernier.com.